So we're going to look at a central angle. So a central angle is one that has the vertex on the center of the circle, and then goes to the edges, right? So if we had, like this is the center of our circle, this right here would be the central angle. Okay. And then we also have something called the minor arc and the major arc. Okay, so the minor arc is the points on the circle that are on the interior and side of the central angle. Okay. So this right here would be the minor arc. Okay. Then we have something called the major arc. It's the points on the circle that are on the exterior and side of the central angle. So this would be the major arc. Okay. We also have a semicircle that you should be aware of. The endpoints of an arc are the endpoints of the diameter, right? So then you just end up having on your circle, this part here would be, oh, let's do blue, no, yellow. This part here would be your semicircle. Okay. Now, because we have central angles and arcs, we need to know how to name them. So we already know how to name angles. We can use still our 3 letters. So this would be cab, or you could do angle back. But we need to know how to name arcs. So arcs would be like the crust of a pizza, or the crust of a pie. Okay? So we name them by their endpoints, which is similar to segments, but we have an arc drawn above it. Okay? For major arcs, you have to add an extra point and use that so that we can differentiate between the minor arc versus the major arc. So on this one, I would call this AB. Oh, no, not A at all. CB. So this part would be CB. And then if I wanted to say this arc, that's the major arc, I would say arc CDB. I could also do BDC. Notice, again, if we follow BDC or CDB, it makes that arc. Whereas if I follow CB, it makes that arc as well. Now, we now know how to name them, but how do we measure them? Okay. So for a minor arc, the measure of the minor arc is the same as the central. It says arc, it's supposed to be angle. Okay. And then the measure of the major arc is 360 minus the minor angle. Okay. So that's how we measure our arcs, by using the central angle. Okay. So for example here, if I want to find the measurement, we use that M beforehand of arc CB, then that would be, since our central angle of CB, so this is our arc CB, since that central angle is cab, and we know that's 75, I just wrote over it over here, but then that means that the arc has to be 75 as well. So try these two. Okay, so if we look at this one, the measurement of arc CB has to be 45 degrees because the measurement of the central angle is 45. And then here, the mark of BD, or the measurement of arc BD, has to be 112 because that is the measurement of the central angle. Okay? So now if we do the major arc, so here if I want the measurement of CDB, what I'm going to do, because around the entire circle is 360, what I'm going to do is 360 minus that 75. So if we do 360 minus that 75, that just gives us 285. Okay? And we can do the same thing here. So try it on these two. Okay, so here the measurement of CDB is going to be 360 minus 45. So if we do 360 minus the 45, that leaves us with 315. Ooh, that needed to be arced. So that's 315. And then on this one, If I do the measurement of BED, that's the major arc associated with this minor arc. We're going to do 360 minus the 112. So if we do 360 minus the 112, then that leaves us with 248. Now, similar to our angle addition postulate, you also have an arc addition postulate. So before, our angle addition postulate was saying the part plus the part equals the whole thing, where we also had a segment addition postulate where we said part plus part equals the whole thing. So you do the same kind of thing with your arc addition postulate. You're doing two parts added together equal the whole thing. Okay? So if I take this arc and I add those together, that will equal this arc here. Okay? Or if I add this one plus this one plus this one, that will equal this arc here. Okay? Now the other thing that we want is to talk about congruent arcs. So congruent means that two arcs of the same circle or congruent circles have the same measure. Okay? So if we look here, if I want to find the measurement of arc EC, well, the central angle for EC is 70, so that means that this is 70. If I want to find the measurement of ED, well, the central angle is 45, so that means this arc is 45. Okay. And then if we know that the central angle of CAB is 110, then we know that the measurement of CB is 110. So if I wanted to find the measurement of DCB, so D is here, C is here, B is here, I would have to add all three of those together. So if I do the 45 plus the 70 plus the 110, that gives us that this equals 225 degrees. Okay. So now we have a couple of theorems that are related to central angles and arcs and segments. Okay. So in the same circle or congruent circles, two minor arcs, so remember this one's a minor arc, are congruent if and only if their corresponding chords are congruent. Okay? So if we were to look at this arc, I don't have a great picture of that. Here we go. If I do this arc here and this arc here, okay, then because we know that the segment or the chord, because we've got endpoints here, that was our word that we learned the other day. So if the chord for that minor arc is congruent to the chord for the other minor arc, then those arcs have to be congruent. So if we know that this is the same as this, then we know that this chord is congruent to this chord. And you can go the other way as well. So if I know the chords are congruent, then I know the arcs are congruent. If we know the arcs are congruent, then we know the chords are congruent. You can go both directions. Okay? So if we look here at this one, okay, this is our minor arc that we have here that we're looking at. And this is the other minor arc that we have that we're looking at. Oh, I erased what I wanted. Okay. Now, if I look at the segment or chord that's connecting those minor arcs, notice we have that those are congruent. So if the chords are congruent, then that means that we can set the arcs equal to each other. So the measurements of the arcs have to be the same. So we have to set up 10x equals 8x plus 24. So I'm going to subtract 8x. So I get 2x equals 24. So then I'm going to divide by 2. So x is 12. Okay. If we look at this one, notice we've got two arcs that we're looking at. We've got HG, but we also have JI. Okay? And here we know that the chords, nope, not the right word. The arcs, the minor arcs are congruent. So we know that 75 equals 75. So that means that their chord, which is a segment that contains the minor arc, has to be congruent. So then we know that these two need to be the same measurement because the arcs are congruent. So then I can set 2x minus 3 equal to 15. So I add that 3 to the other side. So that gives us 2x equals 18. So then x is 9. Okay. If we look at the next theorem, it says if a diameter of a circle is perpendicular, remember that means at 90 degrees, to a chord, remember our chord is a segment, then the diameter bisects the chord. Okay? So here we have a diameter. If it's perpendicular to a chord, so here's a chord, so we know if it's perpendicular, okay, that it has to bisect the chord, which is this part, and the arc. So we know that this is congruent to this, and we also know that the arc is congruent to the arc. Okay. So then what we have, now notice this was a theorem that we had before. So this is a radius, this is a radius, so these two would have to be the same. You know that this is the same here, and you know that the angle is the same here, so you have a hypotenuse and a leg, so this would create a hypotenuse leg congruent triangles, which is how we know that those two are congruent. And then we have the additional add-in that the minor arcs are congruent, or bisected rather, and congruent. So if we have this, notice this is a diameter. I know this is a diameter because it goes through the center of K. We know that it's perpendicular because of this sign right here. So that means, well, I now know that these two are congruent. So I can set 2x equal to 3x minus 8. So I'm going to subtract the 3x to the other side. So I have negative x equals negative 8. So I times or divide by a negative 1. So I end up with x is 8. But notice our question is to find Pn. So now I need to plug that in. So Pn is going to be 2 times 8, which gives us 16. Okay. Now we can also go the other direction. So if we have a chord that's perpendicular, that is a perpendicular bisector of another chord, then the first chord is the diameter. So if this chord is a perpendicular bisector of this one, then we know that this is the diameter. Okay. So we know here, because this is perpendicular, since SR is a perpendicular bisector of UT, then SR is a diameter. Okay. Then we have the next theorem. In the same circle or congruent circles, two chords, remember that's a segment, are congruent if and only if they are equidistant from the center. If and only if means it's true backwards and forwards. So you can switch the hypothesis and conclusion. So remember that when we're talking about equidistance, we measure perpendicularly. Okay? So if we know that AB is congruent to CD, then we know that WG is congruent to WE. Or if I had WG was congruent to WE, then we would know that these chords are congruent. Okay? Now it has to be that perpendicular measurement, because when we're talking about equidistant, we measure that distance perpendicularly. Okay? So here, I know that this chord matches this chord, which means the distance from the center to that chord perpendicularly has to be the same. So 2x minus 8 has to equal 6. So then I'm going to add the 8 to the other side. So if we do the 8 plus 6, that gives us 14. Oops. And then I divide by the 2, so then that gives us that our x is 7. Okay? So we have several new things that we looked at. We looked at what a central angle is, how do we find the measurement of an arc, how do we name arcs, the difference between a minor and a major arc, the arc addition postulate, and then if we know chords are congruent, then we know their minor arcs are congruent. Or if we know the minor arcs are congruent, then we know that the chords containing those minor arcs are congruent. If you have a diameter and it's perpendicular to a chord, then you know that it's a perpendicular bisector, or vice versa. And if you have a line that's one chord that's perpendicular to another chord, then that first chord has to be the diameter. And then if you know that the minor chords are congruent, then they are equidistant from the center, measured perpendicularly. Or if we know that this distance is the same, then it would be, if we know this distance is the same, then we know that the chords are congruent.